In this tutorial, we will learn how to determine the endpoint and how to record the titration data. Let's start with determining the endpoint. This is the titration setup. In the burette, we have the acid solution, and in the conical flask, the alkali or the basic solution. We will be adding the acid from the burette into the alkali solution in the conical flask. We have to add few drops of the indicator, which is phenolphthalein, to the conical flask. We will add this indicator to help us observe clearly the endpoint. And when the indicator is added to the alkali solution, the color of the solution will become pink. When enough acid have been added from the burette to neutralize the alkali, the color will change from pink to colorless. So now, after we have added the indicator into the flask, we can start the titration. The acid will flow from the burette into the flask. As the acid flows into the flask, it starts to neutralize the alkali. When we have exactly the amount of acid needed to neutralize the volume of the alkali, the indicator will change color. And then we have to stop the tap, and this will be the endpoint. So the endpoint is the point at which the needed amount of acid is added to the alkali. The first time we run titration will be called trial run, because it's common that we might overshoot the amount of acid needed. So the trial run will help us to find out the approximate endpoint for the titration. And then we will run the titration 2 to 3 times after the trial run to obtain accurate results. So after the trial run, we must add the acid drop by drop to ensure that we didn't miss the endpoint. Now we will move to recording the data. The data collected from the trial run and the 2 accurate runs is shown in this table. So we are interested in 2 volumes, the initial reading of the burette and the final one. Let's now run the titration for the 3rd time and record the data. First of all, don't forget to take the initial reading, which is in this case 13.60 centimeter cube. Of course, we must record the volume to 2 decimal places where the second one is 0 or 5. So we will start the titration. We are adding acid to the alkali. The color is pink at the beginning. As more acid is added, the color will become colorless. When the pink color starts to disappear, we will start adding the acid drop by drop as shown in this animation until the solution becomes colorless. Then this is the endpoint. We will stop the tap and we will take the final reading on the burette, which is in this case 27.05 centimeter cube. We must repeat the titration until at least 2 of our results are in agreement, and this means that the difference between the volumes added shouldn't be more than 0.1 centimeter cube. Let's check our data. To find the volume, we will use this formula. The volume added will be equal to the final reading minus the initial reading. So let's calculate the volume for each of these runs. We will start with the trial. 19.25 minus 5.50, which is equal to 13.75 centimeter cube. For run number 1, 28.80 minus 15.40, and this is equal to 13.40. For the second run, we have 14.80 minus 1.30, which is equal to 13.50. And for the third run, we have 27.05 minus 13.60, and this is equal to 13.45. So the difference between these volumes is no more than 0.1 centimeter cube. This means that our values are in agreement to each other. Again, don't forget to record your data to two decimal places where the second one is 0 or 5. And finally, we have to find the mean or the average volume added, which will be equal to the average of these volumes. So we have 13.40 plus 13.50 plus 13.45 divided by 3 to get the average, and this is equal to 13.45 centimeter cube.